So welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, we do enjoy solving the harder problems, but above all, we also see and appreciate the beauty in the simpler problems. So today we step backwards into the qualifying exam for the MIT 2022 Integration B. And today we look at about 4 problems. The first problem will be problem number 1, that's related to trigonometry. That's the indefinite integral of 1 plus cosine x over x plus sine x. The second problem is problem number 2, which is the definite integral of arc tangent of x plus the arc cotangent of x over x from 0 to square root of 3. The next problem after that was problem number 6, and that is the integral, definite integral from 0 to pi of cosine x plus cosine into bracket x plus cosine x. And the last problem is an indefinite integral of x to the power 3 times sine into bracket x squared. So before I jump into the solution, a big shout out to our subscribers. Thank you so much for entrusting us with that subscription. We don't take it for granted. And that's why we're here. You motivate us to come back here every day or every now and then to try and come up with solutions. So we do appreciate your trust and also the time that you put in to look at some of our solutions. For those of you who are here for the first time, a big thank you for stopping by. I would encourage you also to subscribe. We'll definitely appreciate that. For those of you who are here for a second, third, or fourth time, based on our analytics, just a few of you that have subscribed get to watch our videos. So we encourage you, if you're coming back, to just spend that extra second and press on the subscription button. If you want this notification to be coming to your end, please press on the notification button. Other than that, let's jump on into the solution to these problems. So problem number 1, and that is the integral of 1 plus cosine x over x plus sine x. So something we would want to remind ourselves is that the derivative of a natural logarithm of a function fx is equals to the derivative of a function of fx over fx. And if we look at our integrand here, definitely if we take our denominator to be the function fx, if x plus sine x is equals to fx, you can clearly see that the numerator is the derivative of the denominator. And so the x plus sine x dx is equals to 1 plus cosine x, which means that the integral of 1 plus cosine x over x plus sine x is the natural logarithm of x plus sine x. Obviously, plus an integration constant c. So this is our answer. Very simple problem. Didn't need to take a lot of time. The next problem, that's the integration of the arctangent of x plus arccotangent x over x from 0 to square root of 3. The first thing is we can split these two parts into two separate integrals. So we have an integration of 1 over x times arctangent of x and another integration of 1 over x times the arctangent of x. So we can use integration by parts, and by integration by parts, we mean that if you have two items in your integration or that constitute your integrand, you can take one to be u and another one to be dv, such that if you really look at the differentiation of product, that is what really we look at when we derive the integration of two products. So right here, we consider one to be u, another one to be dv, and then the integration of that product is uv minus the integration of v times du. So for the two integrations, we can consider one to be u1 dv1, another one is u2 dv2. So dv1 can be considered to be 1 over x, such that v1 is natural logarithm of x, right? And then dv2 could be considered to be 1 over x, and also v2 is natural logarithm of x, because we have 1 over x in both integrals. Then u1 could be considered to be arctangent of x, such that du1 is 1 over x squared. Similarly, u2 could be considered to be cotangent of x, such that du2 is negative 1 over 1 plus x squared. Now, as you can see here, du1, du2 are the same, only that the sign is different. So meaning that at some point we'll have things canceling out. So going on to actually solving the problem, the integral of 1 over x times arctangent of x plus the integral of 1 over x plus cotangent of x is, as you can see, u1 v1 is log x times cotangent of x from 1 to root 3 minus inside the integral sign we have v1, which we consider to be log x, times du1, which is 1 over x, 1 plus x squared, plus u2 is log x, v2 arctangent x, again cotangent. Sorry, we made a mistake here. So we just have to replace this with arctangent and not tangent. And then as you can see, instead of minus here, because we have a negative sign on our du2, so this becomes positive, right? This becomes positive. And so this becomes plus, and therefore these two cancel out, and therefore you have a log of root 3 arctangent root 3. Since log of 1 is 0, the lower limits cancel out to 0, and log root 3 arctangent of 3. So log of 1 is 0, so everything on the lower side cancel out. So the square root sign can come as a constant out to a half, log 3. Arctangent of root 3 is pi over 3 plus half log 3. Arcotangent of 3 is pi over 6. And so half times pi over 3 is pi over 6. Half times pi over 6 is pi over 12. Pi over 12 plus pi over 6 is 3 pi over 12, which is pi over 4. It is what we show here, and this is our final answer. Simple as that. Next, our next problem, which is the integral of cosine x into brackets plus cosine x from 0 to pi. How you'd solve this is now you could use the sum of angles within a cosine function. So this is the same as the integral of cosine x times cosine cos x minus sine x sine cosine x. Now, it's easy to look at this and say, okay, if I differentiated cosine cosine x, this is the same as negative sine x cosine x times the derivative of cosine x, which is negative sine x or sine x times sine x. So the negative signs cancel out. So you have sine x sine cosine x. So this is the same as the derivative of cosine cosine x. So what that means is that the integral of cosine x plus cosine x is the same as the integral of cosine x cosine cos x minus the integral of the derivative of cosine cosine x. So what that means is that now we have the integral of cosine cosine x cosine x minus into bracket cosine x from 0 to pi. So cosine x of pi is -1, cosine x, so when x is 0, this is 1. And so cosine of -1 minus cosine 1, since cosine of a negative value is a positive in the region of interest, that means is we have cosine 1 minus cosine 1, which means that the second term is 0. And so we're left with the integral of cosine x times cosine cos x. And it's hard to integrate this problem unless you look at it graphically. So if we draw the graph of cosine x from 0 to pi, right? So we have 0 to pi, it crosses 0 at pi over 2, and it's -1 at pi. We can see that for every value of x within that interval, there is a positive and a negative component that match each other, right? And since we also know that cosine of a negative value is positive, so at this point here, the sign generated by the cosine function is going to be what is primary, and so there won't be any canceling out. Whatever will be created by the cosine function will just be a positive value. But they are corresponding. So there'll be a canceling out of the area across these two regions, 0 to pi over 2 and pi over 2 to pi, because this area is negative and this area is going to be positive. So essentially what that means is there's going to be corresponding values all across. And so the answer of that integration is 0. And that last part needed a visualization of the graph of cosine x. You definitely could try the harder way and use complex functions. One other way is to see that cosine x here is a value less than or between -1 and +1. And so you could use Maclaurin's or Taylor's expansion and multiply cosine x by the Taylor expansion of this function and try to integrate it. And that hopefully should drive you towards 0. but a quick look at the graph should be clear enough to tell you the answer. Problem number 7, the integration of x cubed times sine of x squared. Here, the first thing I'd want to do is, if I differentiated half x squared times cosine x squared, I will get half x squared times the derivative of cosine x squared plus half cosine x squared times the derivative of x squared, right? And that is negative x cubed sine x squared plus x cosine x, right? What that means is that this second term here is the same as half the derivative of sine x squared. So this first part on the right-hand side is the same as our integrand. So if we rearrange things, we see that x cubed sine x squared is the same as half, because I've taken this constant out, derivative, so it's half of the derivative of sine x squared minus the derivative of half x cosine x squared. Therefore, if you now plug in the integration sign on the left-hand side, on the right-hand side, we have the derivative of half, derivative of the integration of half, the derivative of sine x squared minus derivative of half x cosine x squared. So integrating those derivative differentiations, you now get x squared minus x cosine x squared. So x squared, sine x squared comes from here, and then half x cosine x squared comes from here, plus a constant. And this is the answer. So it really just needed a quick inspection and then rearranging things around. And that is, that's the end of our problem set today. Thank you so much for hanging around with us. It's been a real pleasure. So next time we'll complete the remaining 4 problems that are remaining in the qualifying exam. Thank you for hanging out with us. Until next time, bye-bye.